Hello everyone, and welcome to our presentation of ACAM revealing relations between humans and sensing devices through an anthropomorphic webcam. I am Marc Teyssier.
And I am Marion Koelle. Our paper is a joint work with our colleagues Paul Strohmeier, Bruno Fruchard, and Jürgen Steimle, all from the HCI lab at Saarland University and Saarland Informatics campus.
To get started, we want first to give you a sense of what is ACAM and why we built this device.
Everywhere we go, we are surrounded by sensing devices. There are surveillance cameras in the streets. At home, Alexa might be listening to us, and a Google Nest Hub might be watching over our sleep. These sensing devices become invisible. They blend into our everyday lives, and we might become unaware of their presence.
As a result, we might stop questioning how they look, sense, and act. And there is many questions to ask. How does their presence affect our behavior? How understandable are their functions? And to discuss those questions, we wanted to take one object as example.
There's probably one sensing device that you all have nearby. It's familiar, everybody can relate to it, and knows how it works.
It's the webcam that is at the same time essential and raises interesting privacy issues. But how to redesign a webcam and why? A webcam and a human eye share the same purpose. They see their surroundings. But in contrast to the webcam, the human eyes are expressive. Human eyes can express happiness, hunger, boredom, or fatigue. They can look curious, distracted, or focused. ACAM is a webcam shaped like a human eye. It can see, blink, look around, and observe users. It works like a plug-and-play webcam, but it also replicates the human eye's movements. We don't see ACAM as a product, but we use it as a tangible and speculative tool to reflect on possible user scenarios and their impact for ubiquitous design sensing.
Our paper presents a variety of design fixes. To come up with these, we used a mixed method approach which included focused brainstorming activities, but also insights from experiencing the device sitting in our lab. The scenarios presented in our paper include Eyecam as a mediator, observer, mirror, ambient presence, and agent.
Let us take you on a brief tour to give you an impression of how these roles might look like and what type of questions it might open up.
Eyecam shows awareness. It opens or closes its eyelids, might even wake up on its own. It also indicates in which direction it's looking.
Extrapolated to other sensing devices, this illustrates what we might be missing. Can we make perceptible what is sensed? Or how much agency would be granted to a smart sensing device?
In the design process, we created several skins for Eyecam with various pigmentation and texture. This made us realize how Eyecam can be a replica of ourselves. Imagine gifting your Eyecam to your remote loved ones. Imagine it reflecting your emotion when you video chat with them. But can we really bridge the gap between co-located and remote communication through a behavioral device?
ACAM is also a very expressive device because it can express a variety of facial emotions. We can wonder and speculate about the nature of our relationship with devices. How can we highlight the bondings we have with the device? How much sensing is needed to create empathy? Could it elicit behavior change?
When we experienced Eyecam in our lab, it sat there as an ambient presence. It was just there, looking at people passing by, seeing everybody. We considered telling it to stop watching. This highlights that we need to ask, where's the line between communicative and intrusive? Can we learn from human communication?
ACAM is uncanny, unusual, and weird. But its goal is to spark speculation on devices' aestheticism and functions. We challenge conventional relationship with sensing devices and see our paper rather than as a starting point than as an answer. And we invite you as a researcher, as a designer, to contribute to the discussion.
As final words, it's time to rethink the relationship between humans and sensing devices through novel design. And that's why we did Eyecam.